Let's go to LeetCode 79 word search. For this question, it gave us a two-dimensional array board char array, and also our word, which is a string. Trying to see whether we can from any cell of the board, start from any cell of the board, if we can find such a path. To see whether this path for every character, if we go through this kind of path, it will form a string of the word. If we find such a path which form the string of the word, then return true, otherwise return false. So what we think about for this question is that we go through every cell in the board trying to do DFS, right? And for each cell, we can go right, down, left, up, right? So the trim go to the next chart, right? The trim condition will be whether this character will be the word, the next character, right? We can have an index for this word. And also some of the other trim conditions that, for example, bounds, right? Also the length, the path of the length should be equal to the word. So if we in any from start any cell, we find a path which we can form a word, we can terminate early return true. Otherwise, if we iterate the whole board, we cannot find the path, we return false. So let's begin to write code for this. Let's have the corner cases here. That is if border equals not or border of length equals 0. We just return false. Okay? And inter m equals border dot length. M equals to border 0 dot length. Okay. And we convert this word to char array. Array equals word to char array. And we have the length equals array dot length. we're going to use a Boolean weighted array, Boolean two-dimensional. Weighted with new Boolean m. So we are going to iterate for each inter row equals 0, row is smaller than m, row plus plus. For input column equals 0, column goes smaller than n, column plus 1. So we are going to use a DFS. For this DFS, that is it will have a return type, the true or false. So let's say if DFS something, right, then we can that is if it's return true, that means we find a path. We can terminate early, return true. Otherwise, return false, right? We start from this row and column. We'll have visited row column equal true. And after this DFS, we're going to backtrack visited row column equals false, right? So private, we're going to write a DFS function for this Boolean DFS. Yeah. So first thing is that we need to pass in this char array board. And we need to have the starter. We need to have the row and the column, right? The current position row and column, right? And we pass in this char array. We already convert this to char array, and we need to have the index in the char array, right? We need to have the Boolean weighted Of course, we can also pass in those kind of things like MN, so that we don't need to calculate its length and width every time, right? So you've got the DFX function. So let's say if so what we need to for this DFS is that we need to go to this index, right? So we can also have its length out so that we don't need to calculate this length anymore. So we'll say if this index already equals length minus 1, we just need to return the board row column equals array index. The thing is that here we cannot write this is one of the tricky things that sometimes we want to say if index equals length, return true, right? But the thing is that because we are going to have the termination, like the chain will not go to the board. So what we need that is we will last chart try to see whether it the chart equals. So right like this, if index equals length, because the thing is that if going like this way, right? It's just in a board. We cannot go to any directions anymore, right? So here, one of the attribute things that we have to say if index equals length equals 1, then return the last character equals the word's last character. So this is one thing to remind. And also for let's say if array index doesn't equal to word row column, right? But if pass, it is just return false. Right? We'll have 4 directions to go to the next row, right? So we can have a private static banner int row equals and we're going to private static panel int we column was so this is the 4 directions, right? What's this? So now from current row in the column, we want to go to its neighbor, right? So we have 4 directions trying to see whether okay, I think this is fine, right? For int k equals 0, k is smaller than 4, k plus plus. So we'll have int new row equals 0 plus d rho k, and in the new column equals column plus d column k, right? Here are the things that in this path, if we visited. So the first thing is that if new row smaller than 0, or new row greater or equal to m, or this is a bound, right? Or new column smaller than 0, or new column greater or equal to n, right? That means that this other one we are going to continue. Also, if this new column in the past is good, new column will also continue. So we'll say related new column equals true, right? Then we'll have DFS and related new column equals false, right? So if return true, right? If DFS for new row, new column array. Now we move to the next index plus 1, right? And length, okay. Relative. We just we can terminate the early return true. For every pass, but DFS will finish after return false. And when we write this, right, so that will be bold. At beginning, we are going to row, column, array. At the beginning, the index is 0, right? And we have m and length relative. And then for the time complexity, right? So we are trying to, the worst case that is we start from every cell, right? Every cell that will be m multiplied by n, right? For each cell, the worst case is that we iterate like a word length, right? So this word will be multiplied by every length. It will have four kind of combinations, right? So 4 multiplied by 4. So 4 multiplied by length, power length. And for space complexity is that we have this one, right? So it will m multiplied by n.